Okay, I think last day we started our new topic, which is about microbit and microcontroller programming. And today we have to continue that. And yes, this part I think we did last day. Okay, so microbit, today we have to continue with that lesson, and I'm going to open your book first. So please open textbook and page, go to the page number, the first page of the lesson. Actually, we discuss about the structure of microbit by now. Then අපි microbit structure එක discuss කරා. ඒතකොට අද lesson එකේ අපි කතා කරන්නේ today's lesson. What we are going to discuss is about how to blink a bulb with microbit as well as Arduino. මේ දෙකෙන්ම Arduino board එකකිනුයි microbit එකකිනුයි කොහොමද bulb එක blink කරන්නේ. ඒතකොට blink කරන එකේ how to control the bulb. So we learn how to control the bulb in this video. Okay, just open the reading book. Let's see. Let's go to the page number which is related to microbit, and here. Okay. So we learn microbit. This is like single board computer or single board. It's similar to a single board computer or single board or single chip computer. So single board computer or single chip computer, and we learn the components of it that we discussed last week. And now I just want to change the code. According to that, I just want to change the output of the circuit, and that is the specialty. Unlike the circuits that we create regularly, that සාමාන්‍ය circuit එකක් හැදුවොත්, unlike the circuit that we are creating regularly, so those circuits, normal circuits, basically we cannot change after solder. So it's remain same. But these circuits we can change by programming. ඒක තමයි වෙනස. සාමාන්‍ය circuit වල වෙනස් කරන්න බෑ. අපි පාස්තලා bulbs පත්තු කරන්න එහෙම හැදුවට පස්සේ bulb එක පත්තු වෙනවා එච්චරයි. Okay, think about your home wiring system. ගෙදර wiring system එක හිතලා බලන්න. Once it is implemented, that is it. When you switch on, it will switch on. When you switch off, it will switch off. That is the only function. But you can't change time to time dynamically, like switch on like a flash bulb and switch on dynamically with dynamic colors. Likewise, time to time you can't change that. If you want to change කරන්න ඕනම නම් wiring එක change කරන්න වෙනවා. But these are not like that. These circuits you can program. Okay, so when you connect the microbit, so this micro USB cable using microbit, it has also USB port. Make it the USB port එකක් තියෙනවා. So mean USB. You can connect this to the computer. When you connect this, it will be displayed as this. And after that, what you have to do? You have to download the code and store here. Make it a download කරන්නයි තියෙන code. So you can just write the code here, and you can download the code, and those downloaded code can be placed inside that connected microbit. Okay, so let's go and see. Okay, I'm going to go to the coding interface, and this is it. So I'll send the link to you. You can also open this. The link is now I have sent to you. And what I need to do, I need to blink this. I need to blink this, and I need to change this. Okay, so I need to blink this at the start. I don't need this. So let's delete this. Right here in the book, you can see there are various chord segments. Either you can start with this chord segment on start, or you can use forever. That will continuously apply. On start can start again with right. Forever will be applied forever. Okay, let's say, let's go to this. Now I'm going to apply forever from this, and I need to show, let's say number 0, and I'm going to run this. You can also do that, and you can see then forever you can see number 0 in this Arduino LED lights. එකේ තියෙනවා LED display එක. දැන් number 0 දිගටම පේනවා. And if I apply something like this, okay, after showing number 0, I just want to I just want to clear the screen. After showing number 0, I just want to clear the screen. Right? So if you apply like this in the real microbit board, at the board apply karana, still in this one you can see it's blinking, but that blinking you will not be able to see. What pain na blinking. So can anyone tell the reason? Samaninde mehemawa blink karana pain na. So show number 0 and clear the screen. You cannot see it blinking. So what's the reason? Can anyone tell?
We haven't put a delay time.
Yeah, we have not put a delay time. So what is delay time? Right? How many seconds or how many milliseconds to keep this status? Okay, let's say I want to keep this status for 1000 milliseconds. 1000 milliseconds means how many seconds? 1 second, right? 1000 millisecond means 1 second. Then I want to show the number 0 for 1 second. And I want to clear the screen for another 1 second. Let's say I want to clear the screen and keep that status for another 1 second. Okay, try this. Try this and tell me what's happening. I want to show the number for 1 second, clear the screen, and then I want to keep that screen cleared for 1 second. What will happen? Yes, what will happen? You can do this and tell me. Show the number for 1 second, number 0 for 1. You can use any number, right? Okay, let's use number 3. Show the number 3 for 1 second and clear this. And then keep 1 second. Or instead of show number, you can use anything, right? You can use number or number, any number 4, any number, number 0, number 4, anything. Yes, what will happen? Can anyone tell?
So it will blink for 1 second and turn off for 1 second.
Yes, it will turn on for 1 second and turn off for 1 second. Tapparyak on vena, tapparyak off vena. Okay, let me increase this. Let me actually decrease the time. I'm keeping 500 milliseconds. And here also 500 milliseconds. Then what will happen? 500 milliseconds, 500 milliseconds. Then what will happen? 500 milliseconds and 500 milliseconds. Then what will happen?
So it will turn on for 500 milliseconds and turn off for 500 milliseconds.
Turn on for 500 milliseconds, turn off for 500 milliseconds. Means, so half of a second. Tapparem bhagayai de. Tapparem bhagayak peenawa meka blink wenawa, light එක පත් වෙනවා, tapparem bhagayak ningila. And I'm going to change this 100. Just put 100 there. Then what will happen? Put in 100 there. Then what will happen? When I decrease the time, yes, blinking speed will be high, right? When I decrease the time, blinking speed will be high. Okay, if I decrease this to 10, what will happen? Decrease this to 10. Then what will happen?
It will rapidly blink, sir.
Yeah, it will rapidly blink, but in the actual situation, you cannot see that. Right? You can do in actual circuit. At the circuit එක කරන්න. කරලා බලන්න මේක. පුළුවන් නම්. මම Arduino වලින් කරලා පෙන්නන්නම්. So Arduino you can do it in actual circuit now, but you don't have this microbit now. So if you have microbit, you can do that. If you don't have microbit, don't worry. Let's do with the Arduino. You can do the same with the Arduino. Arduino එකනේ ඒකම කරන්න පුළුවන්. Right? You can't see this. Okay, so I'll give one example. So if you have light in your room now, room එකේ light එකක් තියෙනවා නම්, just look at that light straight away. කෙලින්ම මේ light එක දිහා බලන්න. And then close your eyes. So what you can see? Look at that light එක දිහා බලාගෙන ඉඳලා එකපාර ඇස් වහන්න. then what you can see?
The image of the light.
Still you can see the light for some time, right? Still illumination, yes, still you can see the illumination for some time, right? The reason is it will take some time to erase the light effect from your eye. The light එක පෙනිලා ඒක නැති වුණාට ඒක erase වෙන්න time එකක් යනවා. ඒ erase වෙන time එක millisecond 10 දුන්නොත් it's not enough. Actually it's erasing from the board, but it is it's not erasing from the eyes. මේ board එකෙන් එක clear වෙලා millisecond 10ක් තියෙනවා තමයි. හැබැයි S දෙකෙන් එක clear වෙලා millisecond 10ක් තියෙන්නේ. ඒ හින්දා අපිට පේනවා we can witness that this light is continuously on. අපිට පේන්නේ මේ light එක continuously on වෙලා වගේ. Right? Because of this faster movement. I think you have seen this in a fan. Fans වලත් තියෙන්නේ. Fans වල පෙති ටික කැරකෙද්දී ඔයාට කියන්න පුළුවන්ද පෙති කීයක් තියෙනවද කියලා fan එකේ? හරියටම. Can you tell that how many wings in the fan? Exactly. You can guess, but you can't tell, right? When it's rotating, because you can't, they can rotate වෙනකොට පේන්නේ නැහැ නේ. Wings වෙනම පේන්නේ නැහැ. Therefore, you cannot say exactly this number of. So think about a wheel. Think about a wheel. When wheel is rotating in a bicycle wheel, you have spokes. What is the spelling? Spoke in bicycle wheel. Is it correct? In the wheel. Is it? Yeah, spokes. So when you have spokes in a bicycle wheel, when it is rotating, can you exactly tell the number when it's rotating? Hello, I'm asking from you. You have never seen bicycle wheel?
Seen, sir.
Seen. When this is rotating, can you count and tell the number?
No, sir.
When it is rotating, you can't count and tell the number. But when it is stopped, you can tell. But ඒක stop slow ගොඩාක් slow නම් කියන්න පුළුවන්. ගොඩාක් slow නම්. But ගොඩාක් වේගෙන් rotate වෙනවා නම් you can't tell that. That is the nature of your eye. ඇහි දෘෂ්ටි විතානේ චිත්‍රයක් ඇඳලා ටිකක් වෙලා යනවා මැකෙන්න. ඒ මැකෙන්න යන time එක මේකේ ඇඳෙනවනේ මේ හතරේ ඉලක්කම ඇහි ඇඳෙනවා. light එක හින්දා. ඇඳුනට පස්සේ ඒක අයින් වෙනවා. අයින් වෙලා තියෙන්නේ millisecond 10යි. ඒ millisecond 10ට ඇහෙන් මැකෙන්නේ නැහැ. Therefore, you can see this as a continuously on light. But actually speaking, so let's take 1 hour. 1 hour of this board, you keep this for 1 hour. So how many minutes this light is turned on? Total number of minutes? පැයක් මේක දිහා බලාගෙන හිටියොත් හරියටම on වෙලා තියෙන කාලය කොච්චරද? පැයක් බලාගෙන හිටියොත්. Yes, actually විනාඩි 30යි නේද? It's only 30 minutes, right? Understood what I'm telling? පැයක් මේක on කරලා තිබ්බොත් මේ board එක ඇත්තටම පත්තු වෙන්නේ විනාඩි 30යි නේද? විනාඩි 30ක් නිවෙනවා. හරියටම භාගයක්. මොකද 10 මේ 20න් 10ක් කියන්නේ දෙකෙන් එකක්. මේ දෙකම එකතු කරාම 20යි 20න් 10ක්. 10 divided by 20. So half of the time this is on, half of the time this is off. Actually it's using half power, right? What on වෙලා වගේ පේනවා bulb එක, but it's using half power, right? It's like a half dim light, right? Sometimes you have seen this. Current එක ගිහිල්ලා මර බාගෙට current එක ආවම තියෙන dim වෙලා වගේ. Then it says power is not enough. You can witness that. It's more off time, less on time. You can do this, right? You can actually do this. More show number 4 for 1 second and 1 millisecond, and then clear screen for 9 milliseconds. Right? Show in for 1 millisecond and clear in for 9 milliseconds. Then you can see very less light, but not here. It's not displayed properly. We'll do this with Arduino. Make it හරියට පේන්නේ. මෙහෙම දුන්නොත් එහෙම, if you give like this, you can see very less light, less amount of light. Why? only one portion out of 10 is turned on. But if you give the reverse, 9 millisecond on, 1 millisecond off, still you cannot see whether that bulb is off. තාම මේක off ද කියලා පේන්නේ නැහැ. හේතුව it's quickly swapping in between the status. You cannot see this is off, but you can see more brighter because 9 milliseconds it's on. That is what you can witness. Okay, let's write this case. Let's write this case and then let's try with the Arduino. Arduino is like, it's more accurate. So this microbit one is like not accurate. So this simulation is not really accurate. Right? But the Arduino one is really accurate. We can try with the Arduino one, right? Okay, let's write this note. Please go to the note and write. Blink LED bulb or a set of bulbs by controlling using code. Blink LED bulb or set of bulbs by controlling using a code. And you can just consider this. Then please write, consider the following microbit code. Consider the following microbit code. And please write the code. Please write the code. Right, okay. Then you can write down this. Don't need to write single note. I'll translate this for you, right? According to this code, according to this code, bulbs will turn on for 100 milliseconds. Bulbs will turn on for 100 milliseconds and turn off for another 100 milliseconds. We can reduce the time and increase the blinking speed. We can reduce the time and increase the blinking speed. Blinking speed. If we continue to reduce, blinking effect will be disappeared at some level. At this stage, human eye cannot recognize off status, as it will take some time to clear the light from eye. You will notice partially illuminated light at this moment. You will notice partially illuminated light at this moment. You can say half dim. Half dim. By that time, we can increase the on time within bracket example 9 millisecond on time. And decrease off time, example 1 millisecond off time. And it will create more illuminated light. Illuminated can deep, more illuminated light, more illuminated light and exposure. By reversing this, within bracket example 1 millisecond on time, 9 millisecond off time. By reversing this, we can generate weak light. We can generate weak light with less exposure. With less exposure. You can do that with the screen also, right? Screen increase in these brightness, decrease in brightness. That is with the screen also. So you do something like this. When you increase the light, will it take more power or less power? More power. So then battery will be lasting for few hours or few minutes. But if you use less power, the phone power when you less the power, so it will last for more hours. You can save battery or the mode, there's a mode called power saving that will dim the backlight. Okay, you can see, you can witness the issue. So what they are doing. So the total on time. Let's consider 1 hour. Let's consider 1 hour with 10 millisecond on and 10 millisecond off. We will notice half bright bulbs, but it will save power as bulbs are off for 30 minutes and on only for 30 minutes. So that is the power saving effect. And likewise, you can increase the power, decrease the power. You can you can create some light which is increasing and decreasing, like that. Ambulance tone, you have heard of it. Yeah, using this effect. Fade in light, you can create using this effect. Fade light. Okay, Tevindu, no issue. Can send the recording. Recording is anyway updated to the site, right? Website now, jits.lk site. Because we have just uploaded the beginning lesson to the module. And now, next set of lessons will be there in the jits.lk site. But it will sometimes, there will be delay, right? There will be small delay uploading. Because we are reworking on that. per week. Actually, we are uploading around closer to 70 videos. So more than 70 videos per week. Right? If there's a 1 week delay, then there will be, if there's 1 week delay, there will be like 100 plus videos. The site is www.gicts.lp. You have to create an account there, and we will add to the corresponding group. So please consider Mr. to recount that. Right. Okay, so finish writing. Or still doing? Come on, give your feedback. Still doing or have finished writing?
Done, sir.
Done.
Yes, sir.
Wait. Need to wait 1 minute. Okay, I'll wait. Just finish quickly. And let's try to do this using. Let's try to do this using Arduino now, so that we can witness, right? If you are doing this using Arduino, we can witness this clearly. Okay, shall we move to the Arduino quickly? Okay, I'm using the simulator because it's visible to you clearly, but I'll practically show this next day. Then you can also wire that wiring කළාම කරන්න පුළුවන් next day. But you can still do the wiring, right? ඕනනම් මම මේක කරද්දී ඔයාලට practically ගෙදර Arduino එක තියෙනවා නම් wiring වලින් කරගන්න පුළුවන්. You can do that. You have to actually install the Arduino IDE. There's IDE, Arduino IDE, Arduino IDE කියලා එකක් තියෙනවා. You can just download that Arduino IDE from arduino.cc site.
So can we download for tab?
For tab, I'm not sure because I have not tested. Better you download for these are the download options. I think they have not given for the tab, but ARM version is there. Sometimes might work for tab, right? Windows, this app is also there, no? Try it, I'm not sure because I have not tested that.
So can I download it from the Play Store?
It seems, right? Because it is there in the Microsoft Store. Play Store, not
Yes.
sure. Microsoft Store is there. Yes, get from the Microsoft Store as an app. Just try it, fine. Search it. Okay, anyway, I'm going to use the simulator. Simulator can be used in any environment. Mobile phone එකේ කවන්න simulator use කරන්න පුළුවන්. This is the simulator and I'll send you the link. Right, if you're having troubles, log into the simulator.
Android version එකේ තියෙනවා sir.
මොකේද පුතේ?
Android version එකේ තියෙනවා.
තියෙනවානේ.
මේ Play Store එකේ.
Okay. හරි, මේකට යන්න simulator එකට. Please go to the Tinkercad simulator. And if you are having problems, right, if you're having problems, log into the simulator, please let me know, then I'll help you, right? මොන හරි ප්‍රශ්න තියෙනවා නම් simulator එකට යන්න එකේ මට කියන්න. I'm going to delete everything and start from the beginning.
So are we using the blocks?
Yeah, we can use the block. Possible. හැමෝටම simulator එක load වුණාද? Load වුණේ නැත්නම් මට කියන්න. අදිති, අනදි, දිහිනි, හිරුක.
link එක ආයෙමත් එවනවද?
link එක ආයෝ නේද? හරි. එහෙම නැත්නම් මම කියන්න දෙයක් නැහැ මේකට. Please go to tinkercad.com. Right? මේකට යන්න. I'm showing from the beginning, right? Go to tinkercad.com. මේ tinkercad.com එකට ගියාම මම steps beginning මුලින් ඉඳන් කියන්නේ. link එක කලින් දාලා තියෙන එකෙන් යන්න පුළුවන්. When you access Tinkercad, there's something called learn or create new design. කියලා එකක් තියෙනවා. Here dashboard you can see create new design. Go to the circuits in the Tinkercad. In the dashboard, go to circuits, then create new circuit. 3D designs වලින් වැඩක් නැහැ මේ වෙලාවේ. Circuits වලට යන්න. Please go to the circuits and create new circuit. And that will navigate you to the link. That will navigate you to the link. This is very good simulator. It's working like actual situation, actual one, right? So I really like this because it's working like same, almost same. It's a very interesting one. Okay, let's close this. And I need, let's do a small one. First, to learn this interface, I just need a battery and LED bulb. I'm going to take a battery, yes, a 3-volt battery, yeah. This coin battery, 3-volt one. And then I'm going to use another one, 1.5-volt battery. This one, a AA battery, this one. And then I need LED, light emitting diode. How to find the plus edge and the minus anode and the cathode in LEDs? Anode and cathode, how to find? The anode is like its length here, right? Digging වැඩි. Anode එක දිග වැඩි. ඔයගොල්ලන්ට ඒවල තියෙන kit වලක් තියෙනවා. Anode එක දිග වැඩි, cathode එක දිග අඩුයි. Anode is the plus. I'm connecting anode to the plus and cathode to the minus. This is a risky one. I'm just trying direct connection of anode and cathode to the battery. Direct connection of anode and cathode to the battery, and this one also just connecting to the anode and cathode, the plus. Okay, let's see. This is 1.5 volt. It's 1.5 volt battery, and this is a 3-volt battery. Okay, let's play the simulation now. And you can see this bulb is like, it's like a dim, but this bulb is, it has more light. Okay, let's increase the number of bulbs, number of batteries, and I'm going to include 2 batteries of, then it will burn, right? If you add 2 batteries, LED will burn, because LED need only 20 milliampere, where I have given 136 milliamperes. Even voltage is low, ampere is high, it will burn the LED. So that is what I really like. Before creating the circuit, you can try. How to reduce this? Make a picture. Then yes, resistor. ප්‍රතිරෝධකයක් යොදා ගන්න පුළුවන්. වැඩින යන ඇම්පියර් ගාන තව කාට හරි දීලා දාන්න ඕන. මම ගන්නවා මේ resistor එකක්. resistor එකක්, do you know the equation? විද්‍යාවේ කරලා තියෙනවද science වලට equation එක? V equal IR. V equal IR කරලා තියෙනවද? නැද්ද?
No, sir.
No. Okay, then science කරන science ඉස්සරහට කරා විද්‍යාවේ. Science වල කරද්දි teacher එකක් කියන මෙහෙම එකකුත් තියෙනවා, teacher we can just do the simulation using this කියලා. Because this is very useful, right, when you're doing science. Okay, so anyway, so let's use 1 kilo ohm one, but that is too heavy, right? 1 kilo ohm can ready. We balamu use 1 kilo ohm resistor. I'm connecting this edge. While develop, resistors up here. Then play the simulation, and you can see light is like this. Light එක අඩුයි. මේකට light එක ඊට වැඩිය වැඩි. But here මේ light එක burn වෙන්නේ නැහැ. හැබැයි මේකේ milliampere ගාන වැඩි. It's getting 61 milliamperes. 61 milliampere, where you need only 20 milliampere for the LED. Sorry.
Tinkercad is not working in my laptop.
Which one? Tinker.
Yes, sir.
Should work. So what's wrong?
Still buffering.
Yeah.
It asking me to sign in.
Yeah, you have to sign in. Yes, you have to sign in with the Google. Google එක sign වෙන්න. Sign in with Google. Gmail එක දෙන්න. Gmail එක දීලා sign in වෙන්න. එතකොට හරි.
Okay.
Anyone else having issues? තව කාටද ප්‍රශ්න තියෙන්නේ? Tinker. Kishalni? Tehara? Are you okay with Tinker? කරනවා නේද පුතේ? කරන්න නැතුව නම් ඉන්න එපා තේරෙන්නේ නැහැ කියලා.
So how to take that battery case?
Battery you can take from here. මේ පැත්තේ තියෙන battery එක drag කරලා ගන්න, click කරලා ගන්න මැද. පුතේ මේ
No, so I
තේරෙන්නේ
mean,
ඔව් කියන්නකෝ.
so the battery case thing that you have.
මේ කේස් එකක්ද? කේස් එකක් ඕනේ. ඔයා මේ බැටරි එකේ ගාණ වැඩි කරාම බැටරි 2 batteries කියවම automatically කේස් එක එනවා. Here 1 battery, 2 batteries, even you can take 3 batteries. Right? 4 batteries. So 1 kilo ohm is very good because it's giving us support. Even with the 4 batteries, you can light the bulb without burning it. Right, but you don't need 4 batteries. Just reduce it to 2 batteries. මේ ඔයගොල්ලන්ට කාට හරි කරගන්න බැරි වුණාද පුතේ? මට චුට්ටක් කියන්න මොකද මම කැමති හැමෝම කරනවා නම් මේක. Otherwise it's like yes.
It's when logging into Tinkercad, it says connection is not private.
It's okay. ඒක continue කරන්න කමක් නැහැ. ඒක ප්‍රශ්නයක් නැහැ. Okay, can you share the screen if someone is having problems? හරි අපි ඒක විසඳගනිමුකෝ ඉස්සෙල්ලාම ප්‍රශ්න තියෙනවා. Please share the screen. So those who are having troubles, please share the screen. හැමෝම ප්‍රශ්න තියෙන කට්ටිය එක එක්කෙනා share කරන්න screen එක. ඉස්සෙල්ලා උදව් කරලිමු කට්ටියට මේක හදාගන්න. Quickly පුතේ. ඉක්මනට share කරන්න. Aditi, are you okay?
Yes, sir.
Right. Anadi. Sadhyak ne. Diman. Dimat ගෙනම් connection එක slow වගේ පොඩ්ඩක්. හරියට. Dimat okay යන්නකො back එකට home page යන්න. Go to the home page. Right. After going to the home page, you can just follow the steps that I said, right? ඒක එන්න පුළුවන්. Create new